Hello, Hafaday, and aloha. Thank you all for joining us again today. Welcome to the seventh and a half webinar in the Pacific Desk 2022 webinar series. I am David Hitzel, the Pacific Desk Guam instructor, and today's topic of discussion is the NOAA HRIT EMWIN satellite broadcast, background, status, and future. Usual reminders before we begin: this is being recorded for educational and documentational purposes and is posted simultaneously on Facebook Live. Please leave any questions that you would like in the comments section, either here on Zoom or in Facebook, and please include your location and affiliation. A period of oral questioning, of course, will be allowed at the end of the talk, but please otherwise refrain from having your video or audio switched on. And then lastly, this is, of course, being recorded, and I will post it later on YouTube and provide everybody on the email list with the URL. Okay, as I mentioned in the email I sent out, this is our final official Pacific Desk webinar before returning to a regular on-site training schedule. However, we may schedule a few sporadic webinars throughout the year. Topics and dates for those 2023 Pacific Desk webinars are to be decided and will be announced in the usual manner through email. The other thing is we're supposedly hiring a student assistant. So I've kind of been, I want to put together an archive page. We did 19 webinars during the pandemic. I think those are useful to present students and to future participants in the program. So I'm kind of waiting till we get that person and have that as one of their tasks to put together an archive, a good archive page on our website. So I'll announce that when that comes out. Okay, and today our speaker is Dr. Ian Avruch. Ian is currently employed as the HRIT EMWIN Program Manager at NOAA NESDIS. He has experience in ground and space-based astronomy, including instrument development and software for processing and analysis. He has been previously involved in the Japanese Space Agency-led VSOP Space Very Long Baseline Interferometer mission, as well as the Cassini mission, which concerned ground-based VLBI tracking of the Huygens probe on Titan, one of Saturn's moons. He has also worked with the ESA-led Herschel Space Observatory. Ian has a doctorate in physics from MIT, where his thesis concerned radio astronomy. His continued interests include efficient processing of data, algorithms for data analysis and discovery, and using satellite observations to monitor and mitigate environmental change. So the purpose of today's webinar is the fact that remote communication capabilities are a prime concern of the Pacific Island communities. The radio and internet for the communication of hydrometeorological and climate-related information, also known as RAINnet, developed the Chatty Beetle in response to this concern, and instruction in the use of this device is a prominent subsection of the Pacific Desk training program. The Chatty Beetle provides weather alerts and notifications to remote locations where communication options are limited. This is in the form of short, simple text-based messaging designed particularly for emergency warning situations. Whereas the Chatty Beetle excels in ensuring previously gathered data within the meteorological community, the combined high-rate information transmission and emergency manager weather information network, or HRIT EMWIN, serves the Pacific Islands in collecting meteorological data in remote locales for forecasting purposes. Some of the more common sources include GOES cloud and moisture imagery in 7 bands, a selection of derived level 2 GOES products, Himawari 9 imagery in 3 bands, and maritime graphical products from the National Hurricane Center. This information is transferred via satellite in near real time and at relatively low cost using very basic hardware. The capability, status, and future of this service is therefore the topic of discussion today. And with that, I will turn it over to Ian to give you many more details on this.
Thank you very much, David.
Sure.
Hello, everybody. Thanks for inviting me to give this presentation. As you heard in the introduction, I don't have a background in meteorology, and that's something of a handicap. Um, so in my discussions with the community, I need to learn from you what is important to you. If you're interested, if you're currently using or you're interested in using HRIT EMWIN to do forecasting or to be warned of weather conditions and emergency situations. HRIT EMWIN is an operational system. It's meant to provide important information in real time.
Sorry, Ian, I can't hear you, and I'm apparently not the only one. Are you there?
Yes, I'm here. Yeah, I was,
Okay.
of course, muted. All right, let me just back up and say that
Okay, yeah,
thanks very much.
back up about 30, 40 seconds there.
Yeah.
Please.
So you heard from David's introduction that I don't have a background in meteorology. My background is in physics, so I'm at a disadvantage with this audience. As a part of my goal and outreach to the potential users, the interested parties, people who perhaps want to use HRIT EMWIN, is to find out what they want to use it for. The current broadcast has been composed knowing judging by my predecessor what would be most useful for the users of the service. And he's done a very good job. But of course, conditions change. And we're always open to suggestions about how the selection of data could be modified on the broadcast. We're up near the top of we're utilizing most of the bandwidth at this time. But there's always a possibility for change. So let me go on. I'll just, the first slide, you've been looking at it for a while, just to say that there's been progression in the ways that NOAA geostationary satellites have been delivering data directly to users. Basically, a change from analog to digital, and an increase in the data bandwidth.
Sorry, Ian.
Yes.
Sorry to interrupt. I'm not actually seeing your slide. I see just your name screen.
Oh.
Yeah.
Well, I've advanced slides. I don't know why it hasn't gone further for you. Is that true for everybody?
Yeah. Are you sharing your screen?
Indeed, I am. Let me just.
There we go.
I'm sorry, everybody. I don't know what's going on.
Could you maybe go back one slide? I don't think anybody else saw that one. Yeah, that one. There we go.
If I convert to slideshow view, do you still see it?
Yep. Yep.
All right. Tell me if it doesn't. I'll indicate when I'm changing slide, and please tell me if it doesn't happen.
Okay.
This slide, we have to get past this slide. This just is to demonstrate that there's been an evolution in the manner in which these NOAA geostationary weather satellites serve data directly to users, going from an analog broadcast to digital and then to higher data rates. These concern previous generations of the geostationary weather satellites. I've changed the slide. Do you see the new slide? Historical transition overview?
Yes, all good.
Oh, all right, thank you. The current system with the GOES-R series is called HRIT, high rate, for high rate information transmission. What has happened is that the emergency manager's weather information network broadcast and the low rate information transmission at two separate frequencies in the previous generation were merged into one frequency, one broadcast for the GOES-R series, and the bandwidth was upped. So this became the high rate information transmission and the emergency manager's weather information network. Um, this transition was complete when GOES 17, the second GOES-R series satellite to become operational, began broadcasting HRIT, and that was in 2019. So these two separate, they had been separate data streams, were merged into one broadcast, and the total bandwidth was upped to 400 kilobits per second. Now the data, but this is not called HRIT EMWIN. I'll just move ahead. So speaking of the GOES-R constellation, here's the current situation in the sky. GOES 18, which was launched last year, has become the operational GOES West as of just a few days ago. GOES 17 has now been, the instruments and the X-band broad transmitter have been turned off, and it's begun its drift. GOES 16 will remain the GOES East operational satellite. So over the course of the next month or 6 weeks, GOES 17 will drift over to a co-location near GOES 14 and enter standby mode. And it will be available for contingencies if there's a problem with either GOES East or GOES West. This is an animation which I grabbed from, I stole it from someone's recent presentation. The eruption of Mauna Loa recently. This was captured by both GOES 17 and GOES 18. 17 is on the left, 18 is on the right, and you can see that 18 provides better data quality than 17 even. There are some artifacts affecting GOES 17 that you can see here. I hope you can see this. I hope that the bandwidth is sufficient for you to see the animation.
Yeah, it looks good.
So what is the data flow like? We have a system with backup. The GOES, I'll explain how the HRIT data stream is put together a bit later, but once the data stream is composed, it's uplinked from one of two locations. The primary location at Wallops Island, which is at the lower right of this image. It's uplinked at S-band to both GOES satellites. There's a backup facility at Fairmont, West Virginia, called CBU, Consolidated Backup Facility, and that also uplinks at S-band. And when it's needed, it can be switched in. The data stream is supplied to both of these locations from our central facility in Suitland, Maryland, the NSOF facility. There's a data pipe there called the Product Distribution and Access Service. It's just a middleman. It takes data that has been pushed from various organizations around the world. EUMETSAT, the Japanese Meteorological Organization, the GOES ground system, and other places, I think. It assembles these data and supplies subscribers with tailored versions of the data on a schedule that they have set. By the way, subscriptions are now closed. I don't think they're accepting new subscribers, but HRIT is one of these subscribers. So the data are cached at what we call the PDA, and they're fed to our broadcast facilities at Wallops Island and Fairmont, West Virginia, where they're uplinked at S-band to both GOES spacecraft. And then there's a transponder, which simply turns the signal around, down converts to L-band, and transmits with hemispherical coverage to users directly. So how is the stream composed? Well, we have if you look at the lower left, we have three basic types. We have uh, text and graphics products from the Emergency Managers Weather Information Network, which are provided to us from the National Weather Service. They compose that set of data and deliver it to us continuously. We have a certain guaranteed bandwidth for that, and it has the highest priority in the queue for broadcast, which means that all of these products, EMWIN, DCS, which I'll describe in a second, and our GOES imagery and other imagery products are coming in um, continuously and also on schedule. Depends on which product. Um, but when EMWIN data comes in, it takes priority in the queue, gets to the front, and is uplinked for transmission to the GOES spacecraft. Uh, In addition, we have some customization of the imagery. We changed the resolution of the, I think, band 2, the visual band for GOES, to lower the total volume of data that has to be sent up because 400 kilobits per second is not a large amount of data. Um, we do some checksums, and we just make sure that priority messages go up first. And at the lower right, you can see the individual streams of data that get pushed to us here at Suitland to NOAA facility, NSOF, and that are put together and compose our HRIT data stream. So the EMWIN data products, um, we compose our. If you receive our broadcast, we have virtual channels set up for the ease of the user. Not all of your data just falls into a directory. So you can pick which channels you want to monitor. The EMWIN products come on 3 channels. Uh, they're segregated by frequency. So some of these EMWIN channels are more or less continuous, text-based products. Others come less frequently. What is contained? Weather office observations, warnings, watches, radar mosaics for Guam, Hawaii, Puerto Rico, the Caribbean, other graphics products from the Weather and Storm Prediction Centers, and graphical products from the National Hurricane Center. I must admit that I have not checked out all of these products myself that we broadcast. As I say, they're delivered from the National Weather Service. So, and like I say, I'm new in the position. So it's part of my, it's on my list of things to look very carefully at these products to understand exactly what they are. But here's something that I do want to say. We've done some outreach over the last year, and I've learned a lot about how these EMWIN products are used in a very interesting manner, especially within the continental US. Often these EMWIN data are used for things like automatic warning sirens and for automatic systems at chemical plants to warn of approaching severe weather. It turns out it's a very impactful system. And the feedback from the community has been, one person said, who uses these data, that this is NOAA's best kept secret. Not a lot of people know about the valuable data that gets sent over the EMWIN broadcast that can be picked up directly with small satellite receiver systems on the ground. Another type, one of the 3 types, the second type of data that we broadcast are the data collection system, DCS products. DCS is a system, if you don't know about it, of rather small sensor platforms that can be installed in remote locations. A good example are flow gauges in rivers and water height sensors for dams. So, many U.S. government agencies use these systems, like our U.S. Army Corps of Engineers or the U.S. Geological Survey. These sensor platforms broadcast their data directly up at 400 megahertz to the GOES geostationary spacecraft where they're turned around and broadcast back down at L-band with hemispherical coverage. So it's a completely separate system to the HRIT. I mean, it's an independent system, has its own transponder on the GO spacecraft, but the data are also assembled in the product distribution and access system, and so they're available to HRIT. So we broadcast all of these messages at a slightly higher latency than you would get if you had your own receiver at the particular frequency for DCS. But still, it's a latency of generally less than 5 seconds from the measurement by the broadcast, the uplink from the sensor to the spacecraft back through HRIT to you. And we broadcast imagery products. Most of our bandwidth actually is taken up by the broadcast of GO's imagery products. We broadcast 7 bands, including band 2, visual band. But of course, the infrared bands are very interesting. The GO spacecraft, of course, produces these data with a 10-second cadence, usually a full disk every, 10 minutes, pardon me, every 10 minutes. We don't have the bandwidth to broadcast all of that. So we generally broadcast these full disk images twice per hour. We broadcast other graphics products too, including the derived products from GOES. For instance, cloud top height. You can see the list here. We also broadcast, and there's a misprint, Himawari 9 now imagery in 3 bands, which are supplied to us from the Japanese Meteorological Agency. And during supplemental operations, if there's a contingency, a problem with one of the GOES spacecraft, 17 or 18, goes east or west, we can substitute GOES 15 data. We have done so in the past, but not during my time here so far. This is what the current broadcast looks like. The channel definitions are on the left. Description of the product name is on the second column. CMI means cloud and moisture imagery. And then you see on which spacecraft these products are broadcast. Generally, it's on both, but there is some slight difference. For instance, of course, we don't broadcast Himawari 9 data on GOES east. We only broadcast it on GOES west. Now, the user community is fairly large. It's composed, I think, primarily of government users. This figure is, I've inherited this figure, and honestly, I can't say whether it's out of date or not because there's no need to register, of course, as an HRIT EMWIN user. The broadcast is in an open format, and there's a large hobbyist community that has produced homebrew setups, hardware and software, for decoding the data. So we don't actually know everybody who's receiving the data. I think that's an attractive feature of it. It's available to anybody who wants it, and there's no hurdle apart from setting up the system. How to receive? Well, here I've given some of the standard links about where you can find out the hardware requirements, software requirements, the details of the signal. This is for your reference. But I just want to point out that there are both turnkey solutions available, turnkey systems. We use one of these at NSOF, the NOAA office where I work, to monitor the broadcast directly. Here on the left, you see 1.2 meter offset fed parabolic dishes that we use to monitor the signal ourselves. And we use one of the turnkey solutions. But there's a large hobbyist community, and on the right, you can see a picture that was shared with us from someone who was interested in receiving it and set up his own antennas. Those are about 1 meter I wrote 0.61. I think they're slightly bigger, about 1 meter um, grid antennas for 1.7 gigahertz. Here are some details of the signal, which again is just for your, what's the word, for background. Now, I want to talk about the future. Um, we, uh, we conducted some outreach this summer because at this moment, well, actually, as of December 14th, the next generation geostationary satellite program was approved by the Department of Commerce. NOAA is inside the Department of Commerce. So they approved this program. Therefore, although there are still some planning studies ongoing, I believe now the development phase can begin and contracts can be awarded for spacecraft and instruments. So the next generation geostationary satellites, which is aimed for launch around 2032, is called GeoXO, the Extended Observation System. Instead of 2 satellites, east and west, they're going to be 3. The central satellite will carry the hyperspectral infrared sounder. I'll just skip ahead. The key the key fact as far as HRIT EMWIN is concerned is that HRIT EMWIN and GRB, I haven't described GRB, that's the higher data rate, that's the full resolution data broadcast for the GOES spacecraft. Its GRB is used predominantly by weather prediction institutes, academic institutes. A receiving system for the GOES rebroadcast at L-band would be very expensive. These broadcasts are not going to come directly from the geostationary spacecraft anymore. It's foreseen that they're going to be provided by a commercial system that NOAA will fund. The reason, well, there are many reasons. One is that there's a lot of commercial interest in L-band for terrestrial communications, and it's becoming very difficult to defend the L-band frequency allocations that are used for space communications. Also, NOAA is under the Department of Commerce, and the Department of Commerce, of course, wants to encourage the partnership between private enterprise, and government. So I think it's seen to be a better situation if these. And one more thing, of course, putting these hemispherical broadcasts on the spacecraft involves dedicating power and mass in the budgets to them, and these resources, of course, come at the expense of the scientific instrumentation. So for that reason as well, there's a desire to move these broadcasts off the geostationary spacecraft. So it's I can say now it's practically a certainty that the HRIT EMWIN broadcast or something like it is going to be provided in the future from a commercial broadcast that NOAA will fund. And in a few slides, I'll present an example of what that might be like, which is a current broadcast that NOAA funds through commercial satellites. But the needs of the user community are most important in defining what this future broadcast is going to be. We put some effort into asking the community what they use the current HRIT EMWIN system for and what their needs are. And I want to thank everybody who may be part of this talk who contributed to those surveys. GeoXO, the next generation, is going to produce something like 10 times the data that the current GOES spacecraft produce. So there's a great opportunity for providing more data to geographically remote locations through this future broadcast, which will be a commercial service, but funded by NOAA. There's a great opportunity for more data to users. and we should define what those data will be, what will be of most use. So we're seeking input. And just to point out that um, the goal is to have a broadcast that is at least as good, as reliable and robust as the current HRIT EMWIN broadcast, which is going to continue for the next 10 years. Before I go to this slide, one more thing about L-band. Most likely, the commercial broadcast will not be at L-band. It will likely be at C-band. There are similar broadcasts, like the GeoNetcast Americas broadcast that I'll describe in a minute, and the UMetcast broadcast that covers Europe and Africa, that are at C-band or even at KU-band. There's an advantage to CU-band. Of course, the advantage of CU-band is that there's greater capacity in the commercial broadcast industry for C-band. The hardware is less expensive. What are the disadvantages compared to L-band? Well, L-band, the reason why terrestrial communication providers are interested in it, is the same reason that HRIT users are interested in it. It penetrates weather, it penetrates through water vapor, it penetrates through buildings. So there are advantages to L-band, that's clear. But it's become very difficult to defend the allocations, as I said. So what's foreseen for the next generation is something like this. The one transponder at L-band, which will remain on the spacecraft, are these DCS, the data collection system data transponder that I mentioned. That will remain because it has such a large uptake by government users and others who need, where it protects really vital infrastructure. What can I say about that? I guess that those stakeholders put up a stronger fight than the stakeholders for HRIT EMWIN. So you can see here in this diagram, I wish I could use a laser pointer, but the distribution of what is now called HRIT EMWIN will go through what is considered a medium low rate data service through a commercial satellite provider. NOAA foresees that most data to users is going to go through the cloud. That's certainly true. Just in counting the bytes, most data will go through the cloud. That's true now, and it'll be true in the future. But I'm very concerned about the users at remote locations in the Caribbean and the Pacific, who depend on, in emergency situations, depend on weather information when they might be knocked offline, off the internet, I mean. And NOAA understands this, and so it's the needs of users like that which are going to be protected. And I asked for your help in drafting requirements and getting your input about what kinds of information you would find most useful. And to conclude, I just want to give an example. This has nothing to do, an example of a current broadcast that NOAA funds through commercial providers that you might think of as a model for a future HRIT EMWIN broadcast. This has nothing to do, this is not in any part of an official plan for HRIT EMWIN, but I've become, I'm temporarily a technical contact for this service while NOAA hires a new manager. So I've become familiar with it. The GeoNetcast global network is a collaboration between the Chinese Meteorological Administration, EUMETSAT in Europe, and NOAA in the US. And in this, they cover most of the globe. You see in this figure that it seems that the Pacific is clearly lacking. They cover most of the globe with commercial broadcasts of data at a much higher data rate than HRIT EMWIN is able to manage. The GeoNetcast Americas broadcast goes through Intelsat 21, channel 19C. This is just the only important thing here I want to show you is what the the footprint looks like for the coverage of this commercial service. So once again, this is not an example of what a future HRIT EMWIN system would be. I don't want to give you the wrong impression. I want you to think that the Pacific is not going to be covered. That's not the case. I just want to demonstrate that commercial services right now do provide, at least over land masses and the Caribbean, hemispherical coverage for broadcast of weather information. This is the GNCA broadcast at C-band. And the hardware you need to set this up is very simple. It's very much like the HRIT EMWIN. One key difference is you must buy a license for some commercial software to run this. It's mentioned there. It's called the Kencast FAS-T software, but it's a one-time fee, and once you buy that, then you have the system running as long as you like, and you just have to upgrade your hardware when it breaks. And I want to conclude with these points of contact information. We're definitely going to have, well, as part of the HRIT EMWIN program, we have more or less quarterly meetings, user group meetings. We have a user group. If you want to join the user group and get invited to these meetings, to become aware of future meetings, and even just to provide your input about the future, please send an email to me, either directly, Ian Avruch at NOAA.gov, or to the HRIT manager at NOAA.gov, there in the right-hand column. And that's it.
All right, thank you, Ian. Before I make any comment or ask any questions, does anybody else have a question? You can use your mic, or you can ask through the chat if you'd like to. I hope some people have questions, because I have questions and I don't know that much about this topic to start with. Okay, all right. Well, let me say first, thank you, Ian, again for being available, since you're on the East Coast and it is nighttime, I'm assuming, right now. So on the idea of this HRIT EMWIN being sort of the best kept secret, why is that? Can anything be done about that, or should anything be done about that? It does seem like a very useful tool. And like I said, I don't actually know that much about it, even though I'm working meteorology. And then, so that, I guess that's my first question. And then my second question is, when you were talking about how many of the users are sort of, what would you say? What's the word for it? Amateur, like amateur radio users. Is that it looks like they have it's a fairly simple setup, but it seems like it's something that needs to be set up at home or an office. And is there anything that exists that's sort of like a chatty beetle, like a portable receiver that you could just hook up to your laptop anywhere you go? Or is there anything? If there's not anything like that, is that an idea for creating something like that?
Well, let's see about the best kept secret. I would very much like to improve EMWIN's visibility, especially given that it's so useful for, there's an industry of basically data resellers for EMWIN who get the data mainly from terrestrial feeds, internet, but they also use antennas to receive the signal from the spacecraft directly as a backup. And they oftentimes the customers of these resellers like the fact that the data comes from an antenna and it doesn't depend on the internet. So I would like to improve its visibility. This is something I have to coordinate with the National Weather Service because, of course, they create the data, and I think they know their customers best. So all I can say is that that's a goal of mine. You said, should its visibility be improved? I think so, because my this is a personal statement. My view of the future is one of more extreme weather events and terrestrial infrastructure under greater pressure. And of course, we can devote money to making terrestrial infrastructure more robust. We have to do that. But it seems to me that direct reception from space is a capability that's going to be even more important in the future. And I would like to see that kind of backup being used. I mentioned the data collection system. Many of these, you see, there are a lot of uh, data collection system platforms up in Alaska, for example, and Canada. And even in the US, in the continental US, an HRIT antenna, so a small L-band antenna is used as backup because the internet is not reliable at these remote locations. So if you were at a dam, an example I heard from users, if you're at a dam far from a reliable internet link, you need a satellite backup to get your sensor data. So you asked about portability. I know from speaking to users that there are that small that portable HRIT EMWIN systems are used by the military. I don't know anything more than that about it, but I know that some of the commercial providers of HRIT systems sell to the military, and these are for mobile groups. I know that the Navy has HRIT EMWIN systems on their ships. That's not exactly portable, I guess. But no, I'm interested in the chatty beetle. Maybe could you just, maybe it's not fair for me to ask you a question, but what frequency does that operate at? How does that work, the chatty beetle?
I'm not sure. Ginger, are you on here? My
Hi.
colleague. Yeah.
Yeah. Hi, Ian. It's nice to meet you and thanks for the wonderful presentation. I do see that Graham has a question, so I wanted to just cover EMWIN first, and then I can address Chatty Beetle if that's okay.
Sure, please.
Okay, I can give it over to Graham for your question. You can unmute yourself.
Thank you. Thanks very much for the presentation. Just to introduce myself, my name's Graham Alley from NOAA, way down in New Zealand. I'm here as a bit of a HRIT EMWIN novice, just trying to understand where it might fit. NOAA as an organisation down in New Zealand has quite a presence around the Pacific, and they're always looking at ways to do things better. And one of the things that you said earlier on in the discussion was around the best kept secret, and that was what my question was going to be about, is to, do you have any understanding of who the current users are down in the Pacific region of information that may come out of HRIT EMWIN, just so that we can sort of gauge how most of what we are involved in down here is all around the DCPs, the DCSs, you know, the measurement systems that exist in many of the Pacific Island countries are all things that we have had an involvement with, and we're always looking at better ways to do things. So that's what I'm here for. So my question really was, how many existing users down in the Pacific region, or is it too much of a best kept secret?
Hi, Graham. Thanks for asking that. EMWIN specifically in the Pacific region, I don't know about. But my impression is that EMWIN is the data in EMWIN, apart from the radar mosaics for Guam and Hawaii, the data are mostly continental US. There is another data set provided by the National Weather Service called ISCS that has more international focus. do I have a link to that? Let me see. Well, I can send you a link, or if you go to this website on my contact sheet. I'll paste it into the chat. I'll paste the link into the chat. But there is a different data set that's broadcast by, for instance, the GeoNetcast America service that has more of an international focus. So the answer is I don't know who's using EMWIN in the Pacific. I have a vague idea that the HRIT system is used in, for instance, in Tahiti by Meteo France. I have heard from them, and I know that it's used. Ginger Porter was very helpful and sent me a report, which I don't have in front of me, but I've handed it up to the GeoXO Planning Committee, and I know that there are remote Pacific Island stations that do use HRIT EMWIN.
Okay.
I don't have the list in front of me, sorry.
Thank you. Ginger, do you have a feel for?
Yeah, sure. Ian, can I just share my screen real fast? And then
Yeah, of course.
yeah.
I'll turn myself off here.
Okay, great. So let me pull this up. I guess this is also a good opportunity. We do have our regional partners who are on this call. So greetings to all of you folks as well from the Pacific. So as part of Ian's efforts that he had pushed out, trying to figure out who is a user of EMWIN and HRIT out in the region and where we are as far as the status. And so, there's some of you who are on this call did respond to this reach out. So thanks for that. And so you'll see, generally where we are with the countries and their status with EMWIN and HRIT products. So usable, and then who has a direct feed and who uses it as a backup and how they access the information. So we covered the territory, the trust territories, the Commonwealths, and all the islands. And so this is generally where we are. And I wanted to point out that if you see on the column on the far right, some of them have none and some of them are to be confirmed and so forth. It's because we also went through a whole upgrade process for the current systems that were out in the region. So we had collected all the Quorum feeds. Quorum is the company that we use for their transmission, the feeds. And so we had upgraded theirs to be able to receive the new feed from GOES West, the GOES 18. So that's kind of why they aren't out in the region. But this is where we are, and I'll share this with everybody who's on this call. I'll attach it with the recording of this when David sends it out. But here are, who responded to the survey and their status. So, and I confirmed today that Tonga did just receive 2 EMWIN systems, HRIT, that we had shipped to them. Part of the problem, of course, is the shipping. So it took a while for things to get out into the region. So we sent it out in August and it only arrived in December, and that was through shipping via ocean freight. So, but anyway, so we are pushing out the systems that we've collected from the region. And so returning them to the countries that we received and then upgraded them and then pushing back. And in addition to that, we did have 2 training sessions, one that we had in Fiji and then one that we had in Hawaii at the University of Hawaii. So we are hopeful to have another, kind of upgrade training session for the technical folks. So I see Sean, who's on here from NOAA, and others as well. So thanks for joining us. And so please stand by for that. Hopefully we'll get it this year as borders are opening up as well. But, I'll share this report. It's really short, and you'll see the priorities that the region had identified on what they wanted to see continue on the new feed as we move into the next 20, 30 years. So all the types of alerts that we continue to access, and then other products. So, and then Ian, I think one thing that was very, very important for the region is there was a dedicated page, the Southern Hemisphere page that was there, but it's no longer, it's now an archive, it's no longer there, but that was a useful thing for the meteorological services and the disaster management offices. So it's just, you know, ready, available information that is for the South Pacific. So that's one thing that was very obvious in the responses from the Pacific. So, but with that, I'll end my comments there and turn it back to other comments. Thanks.
Okay, thank you, Ginger. We had a question on the Facebook side. So this is Joseph from the Philippines. He was asking, is there a free certificate of participation? So I think you mentioned, Ian, you mentioned that it's free to get involved with HRIT EMWIN, but maybe not everyone knows where to look to get involved or how to set up a system that'll that is compatible with the HRIT EMWIN. So is there, can you point people in the direction of that possibly? I can imagine they'd be looking, some people would be looking for that.
Yes, certainly. I'm just noticing that I think I failed to include the link in my talk. Oh, no, I didn't. On one of my slides, it says how to receive HRIT EMWIN. There you'll see links to the NOAA sites that provide information about the hardware and software, a manufacturer's list, and there's also a list, a link to the hobbyist site with a lot of good information about building your own system and the open software that's available. So there's a slide in the talk, how to receive HRIT EMWIN. But indeed, you don't have to contact NOAA at all to receive HRIT EMWIN. There's no key necessary, but feel free to contact us if you have any questions.
Okay, so your email was at the beginning of the talk. It's okay if people reach out to you?
Yeah, certainly.
Okay, great. And then, yeah, my question about whether it should be kept the best kept secret was sort of like, I was thinking maybe, are there any traffic issues like with the signal? If too many people are using it, would it slow it down? Or that's really where that came from. I don't.
No, there's no issue there. It's a one-way broadcast. So
Okay.
anybody, there's no, the number of users is not going to affect the quality of the broadcast technically. But of course, content-wise, it will help. The larger the user base, the more important uses it will be put to, and the better NOAA will support it, I think.
Okay, and we got to Graham's question. So if there aren't any more questions, then I'll probably close out the meeting. And you can always ask Ian directly through his email. I will be sending out the recording of this talk. So if there's any slides that you want to refer back to, you'll be able to see it then. And it's also on our Facebook page. You'll be able to view it there immediately afterwards if you'd like to. Yeah, thank you again, Ian. If you want to, if you have any questions about the meteorological side and what might be important, you can always reach out to me. And if I don't know the answer, I'll know who to ask. But yeah, thank you again, and thanks to everybody for joining us. And
yeah, thanks. Can I just say one last thing before
Sure.
which is, if anybody wants to receive the user group emails to get invitations to discussion sessions about the future of HRIT EMWIN, just to get emails about things happening with HRIT EMWIN, send me an email and I'll add you to the list.
okay.
Graham here, one comment. Your thing about chatty beetles, I think the missing answer was Iridium SBD.
That's
Thank
correct.
you.
Yep.
I see that, iridium. Yes, those small portable communications terminals are very impressive. But HRIT does require something like a 1 meter dish.
Good to know. Okay, well, with that, I will close out the meeting and thank you everyone again. So see you at the next webinar and to be decided.
Thank
Goodbye.
you.
Thank
Bye.
you. Bye.